Mechanical equivalent of heat. James Prescott Joule found that the mechanical work done on a system was equal to the heat produced. That is, W is directly proportional to Q, or W is equal to JQ. Thus, Joule's mechanical equivalent of heat is the amount of work that must be performed to produce a unit quantity of heat. Joule's experiment for determining mechanical equivalent of heat. Displayed here is the experimental setup used by Joule to determine the mechanical equivalent of heat. The apparatus used by James Prescott Joule to determine the value of J consisted of a cylindrical calorimeter made of copper. The calorimeter was covered with a watertight lid. Vanes were fixed to the inner wall of the calorimeter. A spindle S carrying a number of paddles was passed through the central hole in the lid of the calorimeter. The shape and spacing of the paddles was so adjusted that these paddles could rotate in between the fixed vanes. The spindle was attached to a drum and a handle, which could be disconnected from the spindle by removing the pin. A string was wound on the drum as shown here. Joule attached two equal masses at the ends of the string that passed over the pulleys P1 and P2. Two vertical scales S1 and S2 were used to measure the heights through which the masses fell. The temperature of the contents of the calorimeter was measured using the thermometer. A known mass of water M1 was taken in the calorimeter. By rotating the handle, the masses were raised through a height h. Again, by rotating the handle in the reverse direction, the weights were allowed to fall down through the same height h. The falling weights rotated the spindle and thereby churned the water contained in the calorimeter. As a result, mechanical work was converted into heat, and the temperature of the water increased. The process was repeated. He noted the rise in temperature in each case. By conducting a series of experiments, Joule found that when the falling weights lost 4.186 kilojoule of mechanical energy, the temperature of 1 kg of water increased by 1 degree Celsius. The value of J obtained by this experiment was 4.15 kilojoules per kilocalories. However, the most accurate value is 4.186 kilojoules per kilocalories. Transformation of energy. The potential energy of the falling masses was converted into kinetic energy and finally into heat energy. Click on the link provided to view the modern setup used for determining the mechanical equivalent of heat. Calculations. Let W be the water equivalent of the calorimeter. Theta 2 minus theta 1 degree Celsius, the rise in temperature of water. H, the height through which each of the masses fall, and N be the number of times the masses fall. Work done by the masses in one fall is equal to 2 mgh. Total work done is equal to 2 mgh into N. Amount of heat produced, Q, is equal to M1 plus W into theta 2 minus theta 1. Now, Joule's mechanical equivalent of heat, J, is equal to W by Q, that is equal to 2 mgh into N by M1 plus W into theta 2 minus theta 1, that is equal to a constant.